All right, good afternoon, everyone. So before we start getting into optimistic UI updates, I think it's necessary for us to talk about what problem optimistic UI is trying to solve. So let's switch over to my demo app here. All right, and so just a real simple app with all the CRUD functionality. And so we'll just go ahead and just try and create a book. Okay, super quick. And if we go through and try and update it, same thing, and then deleting. Worked perfectly. So at this point, you might be thinking that no improvements are needed, the app runs great, we're done. But let's try throttling our network speed. So this can simulate being in an airport, like most of us have been in, being in tunnels, people in countries where they don't have great internet connectivity. And so let's go through our testing once more. So here exactly is the problem that you're seeing. There's no indication on the screen for the user that anything has happened. They hit submit and they get no feedback. And so if we go through and we try and update a book, we're going to see the same thing. So again, no visual feedback, and we have to wait several seconds on a slow connection. And then if we try and delete, just clicking a button, no visual feedback. And a lot of times users are going to then go into like rage clicking, and it can end up leading to them deleting extra records that they didn't mean to delete. And so now they're frustrated because they have to add all those back in. Hopefully they remember all of the information. And so let's switch back over to the slides. So I think it's necessary that we talk about the main question that we're trying to solve with optimistic UI updates. So the question is, how can we provide a better user experience without having any control over the network latency or the server response times? So everyone's seen this. There's a tried and true method of adding a loading spinner. Just throw a loading spinner on in front, everything's better. But can we do better than that? I think we can. So imagine this. Imagine that we take our well-formed GraphQL schema, and we already know what the response is going to look like from the server. So why don't we just mock that? And we just tell our client-side cache, here's what it's going to look like. Here's the data. Just go ahead and add that to the UI. And then we send that off to the server. And if it comes back from the server the same, we're all good. If it comes back different, then we're just going to update the UI with the server information because that's our source of truth. So in today's session, we've got a packed list. So first, I want to clearly define what optimistic UI updates are. And then I think it's necessary that we take a look at the Apollo client cache just to get a refresher on how that works. And then we're going to look at what's called the optimistic response option. And this is key to how optimistic UI updates work. And then I'm going to walk you through example implementations with create, update, and delete mutations. And then we're going to look at some of the errors that you may encounter. And then we're going to look at some more advanced use cases, such as nested types and drag and drop functionality. So first, what are optimistic UI updates? So looking at the Apollo docs, it's often possible to predict the most likely result of a mutation before your GraphQL server returns it. Apollo Client can use this most likely result to update your UI optimistically, making your app feel more responsive to the user. So looking at the client-side cache now, if you've looked at the React docs, this should look familiar. And this is the standard process for any query, whether it's a book with the ID of 5 or really any of your data. So first, the Apollo client requests a book with the ID of 5 from the in-memory cache. And it's not found in there because this is the first time that's been queried. So then the query goes off to the server. Server eventually responds with the book, and then it's put inside that in-memory cache. And then the book gets returned back to our UI, triggers a re-render. Now, if we look at the same exact query a second time, then we see it's a little bit different. So because the book was already in the cache, there's no need to go all the way to the server. It just simply returns it right back, and the result is an instantaneous response. And so this right here is what Optimistic UI Updates leverages in order to make your app feel lightning fast. So let's take a look at that optimistic response option. So if we look at the docs again, we see that Apollo Client stores an optimistic version of the data in its in-memory cache. And then when the server eventually responds, instead of Apollo Client going through the work of trying to diff between that optimistic response and the server response, it's just going to simply replace it, because our server is our source of truth. So we want whatever comes back from the server to be what's in our cache at the end. And so let's walk through that process. So first, optimistic data is added to the cache right when we fire off that mutation. And this triggers all the queries that are related to that data to refresh, and all of the associated UI components to re-render. Then that cache is updated with the server data once the server response comes back, which triggers those queries to refresh again and triggers any associated UI components to re-render a second time. So now the question may come in, oh, sorry, no, we're good. So now that we've got that out of the way and we've had that baseline knowledge, let's start looking through what those implementations look like. So on a create mutation, where we're trying to add a new record that didn't exist before, there's two different things we need to do. First of all, in our use mutation instantiation, we're going to need to add our response data. And this is essentially going to tell our cache explicitly how we want to perform that update. And so in this case, we're looking at like our books being an array. And so we're simply adding in a new record into that array and writing that new array back into the cache. And so then, secondly, when we actually fire off that mutation, then we need to add our optimistic response. And so here's the optimistic response, and this is essentially what the server returns back to us, but there are a couple differences that you'll see here in a second. So the first is that we don't know what the ID is going to be that's on the server because we haven't actually gotten that response back. So what we do in here is we put in just a temporary ID, and that's going to be essentially a placeholder until the server response comes back. And then secondly, we need to put this type name property in here. Usually we don't see this, and if you're using the studio or anything like that, you don't see the type name property, but it's always passing back and forth between the server and the client. And so since we're not actually invoking the server here, we need to provide that on our own. And so let's switch over to our demo app now and see what kind of change that makes to our app. So just as a refresher, I'll try and add a book without Optimistic UI Updates configured. So it takes a few seconds, and there we go. Now let's switch over to version 2, where I've already added that optimistic code, and we'll try it again. Instant. Before the modal even closed, we had our new data in here. All right, so we can switch back over to the slides. All right. So now we've done it with create, let's move on to updates. So just like before, we're going to take our use mutation call, and we're going to add in our cache update logic. Now, this is a lot of code, but this is always going to be business-centric. And so all I'm doing here is I'm just finding the book that's in our cache, and I'm just going to update the information and put it back in. For your use case, it might be different. And then when we fire off that mutation call, just like before, we need to add in the optimistic response. And so here, instead of having a temporary ID, since we actually do know what the ID is going to be, we can go ahead and plug that right in. All right, now if we switch back over, we can see what kind of effect that has. So again, I'll update without the optimistic response. And you see that's still a bit slow. Now I switch over to version 3, and let's try and update that again. Perfect. So now we've got create mutation set up, we've got update mutation set up, and now let's go through what delete mutations look like. So switching back over to the slides. All right, so by now this process should start looking really familiar. So we take our use mutation instantiation, we add our cache update logic. So again, this is going to be business central logic, and so do whatever you need to do. But in here, I'm just taking that books array, finding the book, taking it off of the array. And then we add in our optimistic response option. And this one's missing a couple fields, and so the point I want to make here is that when you're doing different mutations, you want it to match what you expect the server response to be. So if in this case, my server, when you're doing a delete operation, it doesn't need to send back all of the data like the title and the author. All I really need back is just an ID from it, and we need to include the type name for the caching. All right, so let's switch back over to our app and see what effect that has. So if I try and delete without optimistic UI updates, see, just like before, takes a few seconds. And now let's switch over to version 4 where I've got it added. Perfect. So at this point, you might be thinking that we're done, all of our work is good, we can go ahead and ship this. But before we actually ship it, I want to point out an error here. So in the console, if we take a look, we've received this error when we tried to delete. And then let's switch back over to the slides where I've got this blown up for you. So here's that exact same error. And luckily, the Apollo client docs, in this error, they're actually telling us exactly what's going on. They're saying that there's a merge conflict between the array of books that they have in the cache versus the one that we're trying to write back in after we've done the update. Thankfully, they give us clear guidance on how we can resolve this ourselves, which is by defining a custom merge function within our app at the point where we're instantiating our in-memory cache. So here's a basic implementation of the in-memory cache. And then here's what it looks like after we add in our custom merge function. So essentially, we're just saying that we're going to replace the existing array with the new array that we're writing in. But if you're unfamiliar with custom merge functions, let's walk through exactly how this works. So first, we're saying that we want to create a custom type policy. And then we're saying that it's going to be on the query mutation, or the query operations. And we know to do this because if we go back over to our error message, it specifically says that we need to define a custom merge function for the query.books field. And so then, because we know that it's a field that we're wanting to write this merge function for, we use the fields object key. And then because we know that it's the books property that we want to modify, we add that in, we specify that there. And then finally, we define the merge function itself, which, like I said, is simply just going to take the existing array and replace it with the incoming one. Now, for your own apps, you're probably going to want to expand on this custom merge function to perform some validation checks or to ensure that no data is lost or accidentally overwritten, but this works fine for our use case. So that should fix the warning in our console, but there's one other error that I want us to take a look at before we can call it good. So let's switch back over to our demo app so you can see what I'm talking about. So what we're going to try and do is I'm going to add a new book to our list, and then we're going to delete it right away before the server actually responds. All right, so go ahead and add a new book. So I add it, and then immediately delete it. So you see that flash of an error. Let's switch back over to our slides so you can see it once more. So essentially what's happening here is we're trying to delete something that doesn't really exist yet. And so the client is throwing an error and saying, hey, I don't know what to do. Luckily, the fix for this error is going to be simple. All we have to do is we can just disable our update and delete buttons until the server response comes back. That way we know that that record is actually in the server and that it has a real ID, and then we can allow the user to be able to update or delete. So if we go into our React app, we can see that the book list item component has a button and it has a click handler. And so all we do here is we just add in some Boolean logic to determine whether or not we're going to disable those buttons. And then over in our button component, we're going to add in the disabled attribute, and we're also going to update our classes so that our component actually renders as disabled. So in here I'm using Tailwind. Obviously you'll update the classes as you see fit. So now we switch over to our app and we can see what that looks like in practice. So we've already seen the errors, so I'll just switch right over to version 5 where we've got that fixed. So now I go to add a book and you see both of the buttons are disabled, and this is while we're waiting for that server response. And now as soon as they're enabled, I can hit delete, no errors, no problem. So now we truly are ready to ship this code. Let's switch back over to the slides. So now that we've got our app shipped, now I want to talk about a couple more complex use cases. First of all, we currently have a single type, which is just a book, and it has all of the metadata within there. But what if we had nested types? So taking a look at our schema, we have this type of book. And currently we have the author property, which is just a string. And you can imagine that this is just the name of the author. But this doesn't really allow for scalability or addition of new features. And so instead, let's break out the author to be its own type. And so now we have our own type of author, and we have a couple properties on there currently, but you could see where we could add more. We could add what country that the author is from, or what genre the author is in. And now that we've done that on the schema side, now we need to update our optimistic response to include that extra information. And it's going to be the same for all of our options, whether it's create, update, or delete. And so we don't need to go through all of them. I'll just go through this one. So here we're just adding in that author property. And what you'll see is that just like with the book, we need to provide at a minimum the ID and the type name properties. And so with this one, we have a type name of author because that's what we put in our schema. And then we're just adding in the rest of the author fields, which you would assume includes the ID. And if it's a new author when it's being created, then we would include a temporary ID, just like we did for the book. So next, let's take a look at how we would handle drag and drop. So looking at our schema again, before we got into nested types, what we want to do here is, since we're trying to modify the order of our books array, we need to provide some type of property to track what order the book should be displayed in. In this case, I chose to simply add a display order property, which contains an integer value. This additional property is going to allow us to quickly and easily change the order of the books without needing to actually move them around within the array or within our database. So, just like before, we modified our schema. Now we need to modify our optimistic response to include that. But there's two different scenarios we have to handle. The first scenario is we have to handle the item that is actually being dragged and dropped. So using something like React Beautiful D&D, we're getting a destination index for that item that's being dragged and dropped. And so we're going to set the display order property to that index. For all of the other items that are affected, so you can imagine the items that are in between our source index and our destination index, we need to either increment or decrement that display order property so that way it moves up or down the list as it needs to. So now if we switch back to our app, you can see what that looks like. So switching over to version 6, now I can take my properties and move them around. And as you can see, if I switch over to my network tab, we're still on a slow 3G network. And so the server's taking a little bit of time to catch up, but the client doesn't need to know anything about that. The updates are handled immediately. So now if we go back over to the slides. All right, so now we've covered everything that I wanted to get through. But before you go, I'd like to leave you with a few key takeaways. So when adding optimistic UI updates to your app, there are two general steps that you'll need to follow. First, you need to add explicit cache update logic to your use mutation call. Then you'll need to add the optimistic response option to the mutation call itself. Finally, as a tip, remember to always disable or lock any optimistic UI components until they've been replaced by the server ones. This is going to help prevent any transient errors, which are super difficult to debug. All right, and as with every other presentation you've seen this week, I'd appreciate your feedback. Thank you all very much.